All right, let's talk about isotopes. So take a look at this hand and notice that we'll count the thumb as a finger. This person actually has 6 fingers on their hand. And yes, this relates to chemistry. Let me explain. What if I asked you what the average number of fingers on one human hand was? You'd probably say 5. But really, let's say we had some data, and of course, this is not all the people in the world, but let's say you had 6 million people that had 5 fingers, 240,000 people that had 4 fingers, and 1,800 people that had 6 fingers. Again, this is completely made up. I'm sure there's also people with 0, 1, and 2 fingers, and having an extra finger, I'm sure, is much more rare. But anyways, you can see from just, some random data that it's not going to be exactly 5. So my point is that not all atoms of an element are identical. So we're going to get into how they differ. I also want to mention that there are different isotopes that are radioactive, and even your smartphone has radioactive isotopes. And we'll learn more about what it means when something's radioactive and how, it doesn't mean that it's dangerous and you need to get rid of your cell phone. But we'll talk about that more in the next lesson. So your touch screen on a smartphone is made of a thin layer of indium and tin oxide. The indium isotope is IN-115, and we're going to learn what this means. But it emits beta particles as it decays and turns into tin 115. Okay, so all smartphones do have that isotope in them. All right, so let's do a little review before we get to isotopes. All atoms of an element have the same number of protons. So literally every single carbon atom in the entire world has 6 protons. That is what identifies it as a carbon atom. But they can have different numbers of neutrons in the nucleus. So since the mass number of an atom is protons plus neutrons, atoms can have different mass numbers. So an isotope is an atom with the same number of protons, but a different number of neutrons. For example, carbon has 3 different isotopes: carbon 12, carbon 13, and carbon 14. They all have 6 protons. Check it out. 6p positives, because protons are positive. 6p positives, 6p positives. And you can see that carbon 12 only has 6 neutrons compared to carbon 13 has 7 neutrons and carbon 14 has 8 neutrons. So the average mass of all the carbons in the world ends up being 12.011, which means that carbon 12 is the most common isotope. But because of the existence of some rare, but still they exist, carbon 13 and 14, that bumps the average up a little bit. Again, going back to the example of how many fingers on a hand, that is why we don't have an even number. So that's why on the periodic table, you don't see, for most of the elements, an even number. It's an average, so it comes out to be a decimal. All right, test yourself. Which isotope of chlorine would be the most common? Chlorine 35 or chlorine 37? Well, look at the periodic table and look at which the average atomic mass is closer to. So in this case, we can see that chlorine 35 is more common. How do you measure the mass of a tiny atom again? So this is a little bit of a review from the last lesson where we learned about atomic mass units. So the mass of a single atom is called its atomic mass, and the units are labeled AMU. This is based on carbon. 1 AMU is 1/12 of a carbon atom that has a mass of 12. So 6 protons, which are 1 AMU each, and 6 neutrons, which are 1 AMU each. So that forms 12. So just to show you how many AMU are equal to 1 pound, so it would take that many hydrogen atoms to equal 1 pound. So crazy. You'll often see isotopes written like this, where they've got the symbol and then they put the mass number in the upper left and the atomic number in the lower left. And we're going to get a little practice writing those. You'll also see that they name isotopes based on their mass. So cobalt-60. So I always joke, you know, what if it was Miss Baker 120? I wish. And so, yeah, you know, luckily we don't name people after their weights, but atoms are named after their mass number. How would you write the name and the isotope symbol for a potassium atom that has 19 protons, of course, because every potassium has 19 protons, and it has 21 neutrons? So pause the video and see if you can write potassium dash its mass. Remember, protons plus neutrons equal the mass. Going back a slide, see if you can write it in the isotope notation like this. Okay, so pause and take a stab at it. And here are the answers: potassium dash 40, and then the K with 40 in the upper left for the mass, and the 19 in the lower left. Fun fact, you eat this radioactive isotope every time you have a banana. How would you write the name and symbol for an atom that has 15 protons and 17 neutrons? So pause the video. You are going to need a periodic table to look up what element number 15 is, and then you'll need to add up 15 plus 17 to figure out the mass number. All right, check yourself. It should be phosphorus-32 and a P with a 32 in the upper left and a 15 in the lower left. Last but not least, take a minute and see if you can answer these questions about uranium with a 238 and a 92. Uranium 238. How many protons does it have? What is its mass number? And how many neutrons does it have? So pause the video. All right, it's got 92 protons because that's the number in the lower left. It's got a mass of 238, and it has 238 minus 92 neutrons, which is 146. Interesting fact, uranium-238 is found in granite countertops. So our next lesson, we'll talk about nuclear chemistry. It's going to be awesome. Thank you.